Good morning, students. In this lecture, we will discuss about the structure of MOSFET. First, we will start with NMOS structure. So, in NMOS device, current will be carried only by means of electrons. Source and drain both are made up of heavily doped N-type regions fabricated on P-type substrate. This substrate is also called as body or bulk. Source is a terminal which supplies charge carriers and drain is the terminal which collects those charge carriers. Here you can find polysilicon which forms gate, and below that a thin layer of silicon dioxide separating gate and then substrate. The distance between the source and drain, you spell it as length of the channel, and the region perpendicular to the channel you call it as width. So you know now you are able to understood that NMOS device is a device which possesses source, drain, gate and then substrate. Okay, but in addition to that, we have to introduce one more terminal. Observe the figure 2. Here you can find the fourth terminal as bulk terminal. What is the necessity of this bulk terminal means? Normally, the substrate potential will influence the device characteristics. So to reduce that, I am introducing the one more terminal, fourth terminal, bulk terminal. So MOSFET is a 4-terminal device which includes source, drain, gate and substrate. Okay. Next we will move on to PMOS structure. Okay. Here also the same concept, but source and drain both are made up of heavily doped P-type regions fabricated on N substrate. Here current will be carried by means of holes, and here also you can find gate and a thin layer of silicon dioxide insulating gate and then N-type substrate, and then here also you can find the bulk terminal. Next we will move on to CMOS structure. What is meant by CMOS? I already told that CMOS means which includes both PMOS transistor and also NMOS transistor fabricated on the same wafer. Now you see this figure 4. Okay, this particular left off of this particular diagram, source, drain both are made up of N-type and substrate is of P-type, so which results in NMOS transistor. So here you can find one NMOS transistor. Now you observe the right half of this figure 4. Here source, drain both are made up of PMOS transistor. Okay, but if it is a PMOS transistor, it requires N-type substrate. So what can we do? So you create a local substrate which you normally call it as N-well. So source and drain both are heavily doped P-type regions fabricated on a local N-well, which results in PMOS transistor. So now you have placed both NMOS transistor and also PMOS transistor on a single wafer, which results in CMOS transistor. Okay, thank you, students.